everybody. So this particular sheet goes along with the percent composition PowerPoint slide, the slide 20. And what I'm going to do is I'm going to walk you through how to do numbers 1 and 2, and then the rest you'll have to do on your own, but using 1 and 2 as a guide. So what we're being asked to do on this sheet is to determine the percent composition by mass for each of the following substances. So the very first thing we need to do for any of these problems is we need to first calculate the molar mass, because we're going to be dividing the molar mass of each individual element by the molar mass of the compound. So we'll find the molar mass of the compound, and remember how to do that. You just look at the periodic table, find the molar mass of copper, and then add it to the molar mass of the two bromines. And when you do that, there's not a whole lot of room on this particular line for me, but it's 223.35. So 223.35 grams per mole is the molar mass of this compound. Now what we need to do is we need to take each individual element's molar mass and divide it by the molar mass of the compound, because that's how we get percent composition of each one of these elements. So I'll start with copper. And copper's molar mass, again, you just look at the periodic table for this, is 63.546 grams per mole. And we're going to divide that by the molar mass of the entire compound, which is 223.35 grams per mole. Okay? And then you would multiply this number by 100, whatever that number ends up being 100 to get that. And again, this is for the copper. And when you do this, when you do 63.546 divided by 223.35 and multiply that number by 100, you get 28.45%. So by mass, so a little less than 30% of this compound by mass is copper. Then we're going to do it for the bromine. Now we have 2 bromines in this compound. So we have to calculate that. We have to calculate the molar mass of the 2 bromines, because there's not just one bromine in there. We're trying to figure out by mass how much of this is bromine. So we have to calculate the molar mass of the 2 bromines. So that's why I'm going to write 2 times the molar mass of bromine, which is 79.904 grams per mole. We're going to divide that by the molar mass of the entire compound, which is the 223.35 grams per mole. Don't forget, you're going to multiply this by 100 to give you percent. Again, this is the bromine that I'm calculating. So when you do this, when you do 2 times 79.904, and then divide that answer by the 223.35, you get 71.54% is bromine. And that makes sense if you look at this. There's way more by mass of bromine than there is of copper, so you should get a much higher number. And again, this number should add up to 100 or be pretty darn close to that, so that's how you can double check your work. We'll do the next one together. This one has 3 elements in it. It's got nitrogen, hydrogen, and sulfur, so that's why we've got 3 things listed there. So we've got to do the molar mass of the entire compound, which is 68.15. When you're calculating the molar mass of this one, be careful, because this 2 means you have 2 of these. Remember, this 2 means you have 2 of these, so it's really you have 2 N's and you have 8 hydrogens and only 1 sulfur, so be careful with that one. This 2 means you have 2 NH4s. So I'll start with the nitrogen. So we have 2 nitrogens, so 2 times 14.007 grams per mole divided by the whole thing. Okay, and this is going to be for my nitrogen. That'll be times 100. So that comes out to 41.11% nitrogen. And then we'll do the 8, remember, because 2 times 4, there's 8 hydrogens here. 8 times the 1.0079 grams per mole of the hydrogen, divided by the 68.15 grams per mole of the whole thing. Again, this is the hydrogens. When you do that math, don't forget to times it by 100 to get your percent. That comes out to 11.83. And then finally, I'm going to have to put it down here, we'll do the sulfur. There's only 1 sulfur, so 32.065 grams per mole of the sulfur divided by the whole thing, which is 68.15 grams per mole, times 100 to give me percent. This again is sulfur. Do that math out. The 32.065 divided by 68.15 times 100, you will get 47.05%. And again, these should add up to 100. So give the rest of these a try. As always, the answer key is online for you to double check your work. But you shouldn't find these too hard to do at all. It's really just a practical application of the molar mass and practicing that. So you should be fine with this one.